Hello again, dear students. We are in the 4.3 part B, the second part, because we didn't finish this section. So a lot of things. Really, I left this example for you. It's on the page 17. Page 17. Okay. And really, as I told you, you need more work. It's better to be to do it by yourself, but it's okay anyway. I'm going to help you more. Here's example, you can see example number 8. I left as a homework, but I am going to solve it for you, this example, because really in your book they didn't mention many things here. By talking, just by talking or by detail, I'm going to made a table for you here, and that's why you need at least 7 or 10 points to sketch your what do you say, your graph like that. So here we are starting sorry, we are starting to solve this equation. First of all, the function you have f of x is what is equal to x plus 1 square 1 plus x square, and you know the domain of this function is r because the denominator is positive and square, so there is nothing impossible to put some value to here to get the 0 in the denominator. That's why domain of the function will be the r, or you can say minus infinity to infinity. Okay, dear. This is the first step. You should find the domain. The second step, why need the domain? The domain is very good for what? For a critical point. That's why. Okay. This first point, we are going to talk about first derivative, you know, and we will make this one to be 0. So the first derivative, f prime of x, is equal to, I'm going to write really the result, 1 minus x square, okay, 1 plus x square, all of them square, you know how. And this is we will make it to be make to be 0 because we are going to find the critical points. So the denominator is not anything, it's impossible to put anything to be undefined, so we will leave the denominator. It's okay, it's positive part. So for the, and it's positive, why? Because the positive square and all of them square, so that's why whenever you get the negative things in the downs denominators here, so that's why I put the positive. And we will make the denominator to be numerator to be 0, so in that case x square will be 1. In this case you will get minus plus 1. That's the critical point. So c1 will be 1 minus 1 and c2 will be 1. Oh, it depends. So in both cases you need directly, you should use the second step. With the second step you should directly use these critical points to find what? Tell me. Okay, to find the critical point. Think about it. The critical point to find what? To find increase and decrease. How? I'm going to select minus 2 0 2 exactly, and the second step will be putting these test points in here, and you can see directly it's equal to what you can say is equal to negative. Here's positive, as I mentioned for you. So if I put minus 2, I will get negative. Okay, I will get negative part, negative. In the between these one, if I put 0, I will get positive. Okay, if I put 2 here, I will get negative again. So here's the result. I have a decrease, increase, decrease between what? Between minus 1 and 1. Okay, this is the critical points. So this is the table 1. Do not forget about that. So summarize of the table 1, and this third should be the turn of what? The turn of finding the second derivative of x and make it to be 0. So the second derivative of x will be the result will be what? Okay, here's the result. 4x, okay, x minus 3, x squared minus 3, 1 plus x squared, all of them to power 3, right? So after finishing the derivative, directly you can see you get this result, and we will make this one to be 0. Why? Because we need finding the value of what? This is for critical. This one, the first step is for critical. The second, increase, decrease. The third will be for inflection. The fourth will be concave, up and down. So for finding the inflection point, I see that the denominator ever never be 0, because I have a 1 plus the square things and all of them to power 3. So ever never this one, the denominator will be 0. So that's why we leave it. And ever never be negative. So that's why we say also I have a positive here. Okay. So how about here? I say 4x, x squared minus 3 will be 0. Then x equal to 0, or inflection 1, or x squared minus 3 will be 0. So x will be the plus minus square root of 3 with the inflection 2 and inflection 3. Okay, so I'm going to organize it, because in the number 4 I need it. So minus square root 3, 0, and square root of 3, and you know square root of 3 is 2 point something, 2.7. So that's why I'll leave it here, and I'm going to the fourth part. Okay, I'm going to the fourth part of our step for sketching the graph. So I say I have what? I have minus 3, 0, and 3. Again, do not forget about the minus 3 here, for example, minus 1, 1 and 3. So as a test point, I'm selecting this one and putting in the second derivative, and I see that the function will be negative here. Okay, if I put minus 3, look, if I put minus 3, I get 9, which is positive, but this one will make negative, negative, positive, positive. So negative by positive, negative, negative over positive, negative. So that's why I will get negative. Okay, write it down here. Negative means that concave up, down. And if I put, for example, between 0 minus 1 here will be negative, negative, positive. So I will get positive here. I will get positive here, which means that concave up. And I will get between 0 and yes, between 0 and, what you say, it's also positive. Between 0 and, no, it's a negative. I put 1 also give me 1 square, positive, negative, negative. So I will get negative again, concave down. And if I put a number 4 or 3 here, so positive, I'll get concave up. That's all. Now this is the table 2. Do not forget about that. So number 5, step number 5 will be what? Will be collecting all the points here. Okay, how? I have 0, I know I have a 0 here, for example. I have minus 1, 1, 1, and I have minus square root of 3 and square root of 3. Now it's the time to put the table 1 here. So after 1 I have negative, between 1 and minus 1 I have positive, again after 1 I have negative, which means that decrease, this positive, increase, and decrease again. Okay, how about for the table 2? Table 2 means that between after or before the minus 3 we have negative, so between 0 and minus 3 we have a positive, so positive here, again positive, because between minus 3 and 0. How about between 0 and 3 I have negative. How about greater than 0 I have positive. This negative means that up, okay, so because I have a decreasing, I'm writing like that quickly, up just a part, and decrease and concave up, so here's increase and concave up. Okay, what else? Here's up and sorry, I think up, yeah, I'm right. Wait, up and decrease, sorry, it will be like that. Okay, that and that. Okay, and here's between 0 and minus 1 and 0 I have up and positive, so up and positive. Okay, so this one like that, like that, and again I have what? I have down and, what do you say, down and concave, down and increase, so this is down and increase, and this one again down and up, so like that, concave down and decrease, and after 3 we have concave up and what? Concave up and, what do you say, concave up and decrease, concave up and decrease. Okay, like that. So decrease, decrease, increase, increase, you can see decrease, decrease. Okay, so how about here? Down, up, 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 sorry, up, down, down, up. It's okay. Okay, no, this one up and down, sorry. Decrease and concave up, so I have this one. Which part? This one or that one? I have that one, so that's why we erase it. Okay, so that's all about the what do you say, about the graph. Now before sketching we need more things. Number 6, which is about points, important. This means that find the minus 3 and also minus 1 and also 0 and again 1 and finally minus square root 3 and. How you find this one? Important points into f of x, putting of f of x, the function that you have, the put the points here. So because I have not enough time for finding all these points, I'm going to mention some points here. I think we get what? Let me see. Is there any chance? No. No, there's no chance for the points. But I'm going to find it for you. It's better. If I put 1, I will get 2. If I put 1 here, 1 is equal to 2. 2 squared is equal to 4. 1 is equal to 2. 4 multiply 2 divided by 2 is equal to 1. And put the square root of 3. You get some points. If I put 0 here, it's clear. If I put 0 here, I'll get 1 square. If I put 0 also again, so 0 and 1, another point. If I put minus 1 here, minus 1, I will get what? Minus 1 is equal to 0. So how about here? Is equal to 0 over 2. So it's okay. Okay, 0 over 2 is equal to 0. That's all the 3 important points. How about the rest one? I cannot really find it. Maybe you can do it here. It's a little bit difficult, but here's easy. You see it's a 4, because I put the square root of 3 will be 3. So 1 plus 4, 3 is equal to 4. How about here? Is square root of 2 or 3 plus 1 is equal to 3.7. 3.7 will be 9, like nearly to 10. So nearly to 10, 9 point something over 4 is equal to 2.9. Is approximately, not exactly. Just by without calculator, I can do something like that. How? I'll show you how. I substituted the square root of here. So look, square root of 3 plus 1 square over 1 plus square root of 3 square. This one is equal to 4. This one will be 2.7 plus 1 is equal to 3.7 square. And I know 3 square is equal to 9. So this one may be nearly to 9 point, what do you say, 9.789, any things, okay, any numbers, okay. 9 divided by 4 is equal to 2 point something, so 2.9, 2.3. You can say some exactly to not exactly, approximately I can get to 2 point sorry, divide by 4, because the divide by 4, where is it? Okay, here it is. 2 point divided by 4 is not 2. Divided by 4 is equal to you can see square 3.7 multiply 3.7. We will forget about this one. Can see 33 7 is equal to nearly to 10, 9. Yeah, so I'll get what? I'll get some like a 10 is equal to, if divided by 4 is equal to 1.98, something like that, 1.99. So here I get something like I will get here 1.98, and maybe here I get the negative part 0.98 because I have a minus. That's why I get something like that, 0.15075, something like that. I don't know really. I don't care about these points, just for information, but these are very important. The number 7, if you can, x y intersection. This point really didn't mention in your lecture, intersection, and x-axis intersection means that let x be 0, here means that y be 0. In the this function, if x is equal to 0, you will see if x is equal to 0, x 0, 0, you will get what? 1 over 1 is equal to 1. So during x is 0, y will be what? 1. So we have this point already, 0 and 1. How about if y equal to 0, okay, y equal to 0, so the x will be what? It's not easy. You cannot find in this example as easy way. So just try to do it for the easier or the another example. Maybe you can follow it and you can find it. Number 8, asymptotes. Okay. asymptotes, which needs to take the x approach to infinity or x approach to minus infinity. This is for what? For vertical asymptote. You see, horizontal asymptote. Okay, this one, the first part of the asymptote. And also about the vertical asymptote, see if it's a also we have a slant asymptote. We mentioned it in the limits in the chapter 3. So we will take the function. Where's the function? X plus 1, all of them square, over 1 plus x square. So you can see that the limit x approach to infinity, you can find x squared 2x plus 1 over 1 plus x square, and you know if it's infinity we will see the coefficient are equal, so we will get 1. And when x approach to minus infinity also, because they are square, we will also again we will get the 1, so the 1 is y is equal to 1 will be our asymptote. How about vertical asymptote? For the function with the x plus 1 square over 1 plus x square, there is nothing to make the denominator to be 0 to say we have a vertical asymptote. There is nothing make the undefined function, that's why we haven't. How about the slant? We see that in the slant the here should be one more the denominators exponent. So in general, because they are equal, as we see that, so we haven't a slant asymptote. So do not forget y is our vertical asymptote, and we have a note here for the y vertical asymptote. Sorry, for the horizontal asymptote, it's okay to intersect your graph, okay, but here is never will happen, okay, in the vertical. How about the slant? The slant you see also sometimes will happen. Okay, now it's the time for the sketching the graph. We will use number 5, number 6, number 8 much because they are very important. They said this is the summarize of the in front of us steps, and the fourth, from the first to the fourth steps we will collect it in the 5, in the fifth one. And for the points, number 6 is very important, and for the asymptotes also they are important. So if we are, I'm going to sketch this one depending on the table. Depending on the table, look, we have what? As you see, this is like a discussion, not like a lecture, because really we finished the lecture, just we need to apply the, what do you say, the steps. That's why it's not a lecture. Do not say we have many lectures. This is the for you, so like a discussion, like an extra for solving a more example. Okay, so here's the points. We have what, and where's the important points? In the number 8, cell 6, sorry, 0 and 1, and also 1 is asymptote, we know, and we have 0 and 1. Okay, how about minus 1 and 0? Okay, how about 1 and 2? Okay, now we are starting with here. If I have we have a decreasing and concave down, so the function will come like that or like that. Anyway, it's okay if you are not exactly do it whatever you should do, it's okay. But in general, we need the shape. The shape should be satisfy this table. That's all. Okay, so we are starting to here. As we mentioned it, there's something here. We are starting to here like a concave down and decrease. So again, we have between here and there, we have a concave up. Do it by other concave up and decrease again. Concave up and decrease. Okay, decrease and concave up. What else? Later to the minus 1, later to 0 to here, we have what? We have a increase and concave up. Here's increase and concave up. Okay, increase and concave up. Later for this point we have what? We have all again increase and concave down, so like that. So this should be okay. What else? From the between -1 and 3 we have concave up, and we say that it's equal to 1.8 something here. So we have what? We have up and down, concave, decrease and down. So decrease and concave down. And we say what after this? We have decrease and what? Sorry, it was here, not there. It was here, just this part. Okay. And this is the point, not 1 and 2. 1 and 2 is here. It's a point, you can say, no, 1 point something here. Okay. And later from here we have what? We have down and, sorry, we have down and decrease. Okay, dear? So the shape will be like that. I'm doing it again for you in case there's any misunderstanding, because the points are here, there, here, 1 and 2 here, and cubic foot with here's a 1.9. so if it's a 2 here, we have 1.9 here. Okay, all these are the important points that we have, and the image came to here, then again to here, then later go to here, and again, sorry, like that. Okay, here, and then up to here, and then again up to down, and then up to decrease. That's all that you need. Okay, dear? Because you have concave up. So this one is decrease, okay, and concave down till here. How about here? Is decrease, concave up. Okay. How about this? Is increase and concave up. How about this? Is increase but concave down. How about this? Decrease, concave down. How about this? Decrease, concave up. You can see here all the things happen to here. That's all that I say that you need to be careful. Okay. How about the next example? Next example, I think it was took a half on this example because we mentioned all the steps twice, or we repeated this example twice. So that's why I say really you need more practice. This is for the example 4. I'm doing here for you quickly. You can see we have what? We have f of x is equal to x squared plus. First of all, we have a vertical asymptote. Second, we have a slant, because this one is one more than this one. So we have two things. Vertical is equal to 0, and slant also asymptote. How about the derivative? Here's the function. Here's the derivative. First derivative is equal to what? So 0 and minus plus 2 will be our what? Will be our critical point. How about this one? 0 will be our inflection point, but we don't know if I change it or not, so we are going to test it. So first of all, example 9. in your page 18, we have f of x is equal to x squared plus 4 to x. So first of all, first derivative of x will be what? Will be x squared minus 4 over 2x squared. Then from there we have minus plus 2 minus 2, and from this one we have 0 as a critical point, c1, c2, c3. So here's the minus 2, 0 and 2, and I'm going to find what do you say, find and do not forget this one is a vertical asymptote, not include. From here I'm going to see after 2 we have a what? We have an increasing or a decreasing. Okay, find it. You can see so we have here increase. Also here we have a decrease. Here here we have what? We have a decrease. Here we have an increase. Okay, if I am not right, really, I just do it by the quickly on the something. Let me check it for you. For example, if I put 3 here, 3 squared will be negative, so it will be positive, so it's a positive. How about here? Minus 1 will be negative, so it's negative. How about here? 1 will be also negative, so negative. How about if I put 3 squared will be positive, that's all right. So the second, so it's a second. The third, you know, means that increase, decrease, decrease, increase. How about the third step? We will find the second derivative is equal to this one, and you know, at 0 maybe we have inflection point. We don't know. Why we don't know? Because the inflection point depends on the concave up and down. So here for the second derivative, so here should be concave down. Okay, and here will be concave up, that's all. So number 4, number 5, both table is very important. Do not forget about the what do you say about the 0, the vertical asymptote. So 0, minus 2 and 2. We have what? We have after minus 2 we have increase. Okay, I'm just like increase, and I have what? I have down, and also I have a down here. I have a up, increase, decrease, increase. If I am summarizing again this quickly, I have increase and up, so it remains just this one. How about here? Decrease and up, so it remains just here like that, and there's a gap. How about here? I have a decrease and up, increase and up, so it's like that. Okay, dear. So it's the number 5. How about number 6? You say points. Points is equal to, if I put, maybe I put minus 2 something, 0 something, 2 something. Okay, try to find all these points. I think if you put 0 you will get nothing, because 0 is exclude, so you will exclude this one. If I put 2, I will see. If I put 2, I get what? 2 squares for 8 over what? Over 4 is equal to 2. So 2 and 2, and minus 2 and minus 2. Okay, again, because I have x squared, the downs in the denominator we have here, this one will make minus 2. So this is the important point. Number 7, asymptotes. Asymptotes will be horizontal. No, we haven't. How about vertical? Yes, at 0, at x(m) is equal to 0. How about slant? Yes, also we have the slant will be y is equal to x over 2. How I know, please check this one. Check in the chapter 3 we talk about this one many times. So now it's time to sketch the graph by these informations. First of all, we have what? We have a plan, we have a 0, we have a -2 and 2. Here's -2 and -2, -2 and -2. How about here? Here's a 2 and 2. Okay, dear. So how about the slant? We have y is equal to x over 2. So this will be your slant. Okay, will be your slant. How about sorry, this one 1 2. How about this one also? Oh yes, -1 -2. So this one's a PowerPoint. How about applying what do you say? This is our vertical. We don't forget about this one. How about applying this function? We have a up. Okay, we have a up and again down. Sorry, down and down. How about here? We have up and up. Look, down increase, down decrease, down increase, down decrease, and 0 is a vertical. So up decrease, up increase, up decrease, up increase. That's all that we have. We can do it with it. And I think it's nearly to our function, so you can also try to solve this one. It's very important. That's all about really the graph in this section. I made we spent a lot of time for solving this one. This is very important as a review. Look, this one is what? Concave up and what? And increase, concave up and down, up and increase, sorry, down and increase, down and decrease. So this one's up. Okay, you can say increase, up, decrease, up. How about this one? Increase, down, decrease, down. Okay, so you can see the whole rules here. Thank you for watching. Next lecture will be 4.4, and it's totally about different things. It's more easier than this one. 4.3 really is not hard, but really it's with a detail and need more work. Thank you for watching. I'm Dilan. I am Faridun, your instructor in this class, and hope you try to solve all the exercises that I'm giving to you. I'm going to give you, and please try to do your best and study hard. Thank you very much.